Hello everyone, today we will start the new chapter 6. So 6.1 is exponential growth and decay function. So exponential is when you have a constant to the power variable, that's an exponential functions. First is a parent function for exponential growth. Growth means the function will go up, that's a growth function. Generally, we write y equals to b power x. And what is b? B is a real number greater than 1. It's a strictly greater than 1. Then it is a parent function for exponential growth. And the other family, the basic member of the family, remaining can be done calculated using replacing the values, multiply by the values and all. How the graph look like for this? If you look into the graph of this function, it will be this. It's this type of function. It will cut the y-axis at a point 1. So 0, 1 is the intercept, y-intercept, and the function is going up. So it's an increasing function. Always you have to check increasing or decreasing from left to right. When you move your curve from left to right, you are moving up or down. As you are moving up, so it's an increasing function. Increasing function here. And the y-intercept is 1. If you put 1, x value 1, it will be b. The sum point is b. If you put x1, your y value will be b. What about domain and range? Here, x value can be anything. X can be positive, negative, decimal, irrational, whatever. So domain is all reals. What about the range? If you see carefully the graph will not go below x-axis. It will be very close to the x-axis but not going beyond and never cuts the x-axis. So y equals to 0 is the asymptote in this case. What is asymptote? Asymptote is a line. The curve is approaching but not intersecting. So range is all the y values are greater than 0. Not equals to 0, not less than 0. All y values are greater than 0, whatever you substitute x. So y is strictly greater than 0 is the range. Next is the exponential decay function. In the decay, y equals to b power x. Then what is the difference? Difference in the b value. B will be lies 0 to 1. If b lies between 0 to 1 and the function is b power x, it's a exponential decay function. And how the graphs look like? The graph of exponential decay function will be, it comes from up to down. Up to down. Like this. Okay. It cuts the y-axis at the point 0, 1. And this graph is going down if you move right side. So it's a decreasing function. Decreasing function. Domain. X can be any real number. The domain is all real. Range. In the range, your curve is again never going to cross x-axis. So it's very close to x-axis, very close to this, but never going to cross like that. Okay. So range is all values of y but greater than 0, and that's strictly greater. We have to decide whether the function is a growth or an exponential decay. then graph. If you compare with y equals to b power x, here b value is 2. 2 is greater than 1, so this is a growth function. It is a exponential growth function. And how the graph will look like, if you want to draw, growth function will be going up. That's it. 2 power x. At 1 it is 2. Y equals to half x. If you compare y equals to b power x, here b is a half, which is lying between 0 to 1, therefore it's a decay function. Exponential decay. And graph will be goes up to down. Up to down. Okay? Half power. Exponential model. Now we have to learn about how models will look like. Exponential models, how they are. There are two types of model, growth model and decay model. In the growth model, your function will be y equals to a 1 plus r to the power t. In the decay, y equals to a 1 minus r to the power t. A is the starting value, initial value, r is the rate. If it is a rate of growth, I will use this function. If it says rate of decay, then we have to choose this model. It's a growth model, exponential growth model. And that is the exponential decay model. R is the rate. Let's try this question. The value of a car Y can be approximated by the model this, where t is the number of years since the car was new. Tell whether the model represents the exponential growth or exponential decay. Look at this term. The term having a power t. You don't have to count the outside multiple. Choose the number that has a variable. Power as a variable. So 0.85 to the power t. 0.85 is a number less than 1. So therefore it is a decay function. Identify the annual percentage increase or decrease. How much it increase or decrease. If you compare with the decay model, this 1 minus r to the power t. So that means 1 minus r is 0.85. Find r from this. 1 minus 0.85 is r, which is a 0.15 r. In a percentage, it is a 15%. I'm getting the rate of decay is 15% per year. Estimate when the value of the car will be this. So the value of car is getting depleted. It's getting decreased with the time. We have to check after how many years or how many years will take to reach the price of the car $8,000. So y is the price. It should be 8,000. Starting is a 25. Y is in the thousands of dollars. So that means it is not 8. You have to just write 8. It's everything in $1,000. So I write 8, 25.85 to the power t. Divide by 25 both sides. 0.85 to the power t. You can use the calculator and check it at which it intersects. So you will see the value of t will be approximately comes out 7. So after 7 years, the value of car will be $8,000. Okay. Next. In 2000, the world population was about 6.09 billion. During the next 13 years, the world population increased by this each year. So that's the rate of growth. R is given 1.18%. Write exponential growth model. The first of part is the model. Starting is 6.09. 6.09 is the starting. 1 plus the rate. I remove the percentage, so 100 in the denominator to the power t. That's it. Just simplify the inside term. If I try to simplify the inside term, what you will get? You will get 1.018 to the power t. This is the exponential growth model. Then estimate the world population in 2005. This was in 2000 and they're asking for 2005. So that means after 5 years. Substitute t as a 5. Y equals to 6.09, 1.018 to the power 5. If you calculate, what you will get? If I try to calculate this, I will get, that is approximately 6.46, and the quantity is in a billion. It is a billion. Now the B part, estimate the year when the world population was 7 billion. So we have to check when it is 7 billion. You can draw the graph and then check where it intersects the 7. Otherwise, put y as a 7, 6.09, 1.018 to the power 2, and so on. Divide by 6.09, 1.018 to the power 2. Draw the graph where they intersects, that is the answer. If you calculate, the approximate answer will be 12. So after 12 years, you will get, this is the answer. You can directly calculate the value by substitution. Add 5, you are getting 6.4. Substitute 10, substitute 11, 12. So the closest number to 7, that will be the answer. So if you choose 12, you will get the number very close to the 7. Now we have the amount Y in grams of radioactive isotope chromium 51 remaining after T days is this. So this is the model that will tell you the remaining amount of the radioactive isotope after T. T is a time. What percentage decay every year? So we have to find rate of decay. So given is Y equals to A. 0.5 to the power T by 28. How I can rewrite it? I want to convert into time per day. So 0.5 to the power 1 by 28 to the whole power T. Simplify. It will be approximately 0.975 to the power T. And that is a number less than 1. So that means it's a decay model. So how you can write? 0.975 is 1 minus R. R is equals to 1 minus 0.975. So the how much total decay? It will be approximately 0.0245. If you convert into percentage, approximately 2.45% of the total amount is decay every day. Look into this. Next we have a compound interest. We have a questions on compound. compound interest, the formula, only one formula will be used, that is amount is equals to principal 1 plus r over n to the power nt. What is n? P is the principal, r is the rate, n is the number of times it's break for the 1 year. Number of times in 1 year. And A is the total amount adding the interest. N can be 1 if questions say the compound interest annually. If they use the word annual. N value will be 2 if it says semi-annually or half-yearly. N value will be 4 if it say quarterly. N value will be 12 if it say it is monthly. It is monthly. Okay, this is how N value change. If it say the annual interest is compounded annually, compounded quarterly, compounded monthly, so it is changed accordingly. We are provided with deposit amount is this. That means the P value is 9,000. That pays this interest. So that means rate of the interest is 1.46%. Find the balance after 3 years. So that means P is 3. And compounded quarterly means N is 4. Substitute in the formula. 9,000. 1 plus R 1.46. Remove the percentage. 100 will be there. Over N. So divide by 4 to the power 4 times 3. Okay. Next. Simplify this. If you simplify, you will get the approximate answer is $9,402.2. After 3 years, applying the compound interest of 1.46 as a quarterly, you will get the total amount is $9,402.2. Done. Okay. This was 6.1. We have done 6.1 up to this. I hope you understand. If you have any doubt, you can ask in the comment section. Thanks for watching.